Okay, so this might look familiar from last week, but the theme for this week is, instead of working forwards like we were doing last week, where we were taking a diameter or radius and calculating a circumference, we are going to be working backwards, and we're going to do that across a range of examples. So we're going to do it for full circles with circumferences, and then with areas, and then from there, we're going to also reverse the processes we had with our area sector formula and our arc length formula. So we're going to reverse all of those different formulae that we have. So this is our first one. Just like when you're working out a circumference, the very first thing you want to do here is have circumference equals pi d written down. That is our formula that links the circumference and the diameter or the radius. So we start by writing that down. And the key idea here is that you substitute in what you know. So here I know the circumference, so we'll replace with the c with a 50. And we've still got pi d. Now remember, pi is just a number, 3.14. So for solving this equation to find d, we can just divide both sides of our equation by pi. So we can do 50 divided by pi equals d. And so d equals, and we're putting 50 divided by pi in our calculator. Our calculator will turn out 15.915494, etc. We'll round that, which gives us 15.9. Apologies, I've gone off the bottom. 15.92. So key steps: write our formula, put in the numbers that we do know, and then try and solve it like an equation. When we're solving it like an equation, just use our calculator to divide by pi on both sides. And that gave us an answer. Write the full answer and then round it. Now, got a little your turn here. So this one, exactly the same idea. I've given you circumference. We're trying to find the diameter. So have a go, pause the video, try it, and then I will go through the answer in just a moment. Great, so let's run through that one. We've got c equals pi d. Put in the numbers that we know. So we know the circumference, or c, in our formula. So that's 13 is pi times diameter. We'll divide both sides by pi. So we get 13 divided by pi equals d. Once we've got that, we can put 13 divided by pi in our calculator. Turns out 4.1380285, etc. And then we can round it. Now, 2 decimal places will do nicely for all of the examples we're doing here. One thing I have missed, and I missed it on my example as well, I've spotted, was we should have had some units. So centimeters here, and if the circumference is in meters, so is the diameter. Now, with that in mind, there's one other example I'm going to do. Very, very similar, but sometimes just throws people when they see this because it looks a little bit different. So I'll run through this one as well. Again, we're given a circumference. So write down our formula. C equals pi d. Put in what we know. So 9 equals pi d. Divide both sides by pi. And you'll see these steps come in time and time again. We're putting in what we know, dividing both sides by something. These are key steps you'll see time and time again. So we get 9 divided by pi equals d. And so in that case, d equals 2.864788. But we weren't asked for d in the first place. And this is the key difference in this question. We were asked for r. So down here, we want r equals, well, how are the radius and diameter connected? Well, the radius is half the diameter. So we need to divide by 2. That leaves us with 1.4323944 with some more digits on the end here. But rounding to 2 decimal places, 1.43. And I'll remember my units this time, centimeters. So each time, key steps, write a formula down, put in what you know, try and solve the equation, and remember to round at the end. 2 decimal places would be absolutely spot on. So that will give you enough tools to get going on the first questions, but there is a second video showing you how to do very similar process, but where you're given the area instead of the circumference.